Okay, now we want to solve an equation containing rational expressions. Now, if you're given an equation something like this and asked to solve for x, basically, first look you might want to say, well, I have three rational expressions here. Let's get a common denominator, combine them, simplify, and see if we can do something. And that's not a bad approach. That would probably work, but that's a faster way to do it. And it uses the LCD concept here. So let's see what this does. First thing to notice is just take a look at this x squared plus 2x minus 15. And notice that it does factor into the x minus 3 and x plus 5. These are the other two factors there. So if you were to find an LCD, you would actually use x minus 3 times x plus 5 in this equation. Here's what I'm going to do, though. I'm going to take this LCD and multiply both sides of the equation by that. Okay, so in other words, I'm going to take x minus 3, x plus 5 as the LCD, okay, and multiply, well, this whole big rational minus the LCD times this rational expression equals the LCD times this rational expression over here on the right. Okay, let's work out the details over on the left-hand side first. Now, if I took this x minus 3 and x plus 5, multiplied it by this first rational expression, it simplifies pretty easily, doesn't it? X plus 5 times 7x over x squared plus 2x minus 15. Well, remember, this x squared plus 2x minus 15 is just x minus 3, x plus 5. So this actually cancels with this. So that whole thing ends up being 7x. Similarly, if I multiply this second term, the 4 over x minus 3 times x minus 3, x plus 5, can you see it? The x minus 3 is going to cancel, and I'm going to be left with minus 4 over x plus 5. And let's see, how about if I just write that 7x right up front there. Oh, I'm sorry, this is not even 4 over x plus 5, it's 4 times x plus 5, isn't it? Sorry, that was in the numerator all this time. So I'm going to get 7x minus 4 times x plus 5. Okay, that equals, well, let's see what's going to happen over on the other side. Now I'm going to multiply 2 over x plus 5 by this x minus 3, x plus 5. Well, x plus 5 is going to cancel, and I'm left in the numerator with this negative 2 times x minus 3. So in effect, what I've done here by multiplying by the LCD is I've eliminated those denominators altogether. Now that's a technique that you probably used in fraction equations also, and it comes in handy here too. So don't make the mistake I did over here and put one of those things in the denominator, because when you multiply by the LCD, you're actually going to eliminate all these denominators. All right, now let's see what happens here. I'm going to simplify everything. So I've got 7x minus 4x minus 20 on this side. I have negative 2x plus 6 over on this side. This is starting to look pretty easy at this point, right? Let's combine some like terms. 3x minus 20 equals negative 2x plus 6. I'm going to bring the 2x over on this side, end up with a 5x. I'll add a 20 to both sides over here, equals 26. And so finally, x equals 26 over 5. Okay. Now, typically what you would do is you take this 26 over 5 and put it way back into the original equation to verify that it works, and that would provide your final check. So, just as a reminder, you want to check this just to verify. Okay. We'll take another look at another example in a case where why that checking is necessary. But for now, this is the basic technique.